Hi everyone. So this lesson is going to be how to apply the cosine law um, to solve for missing sides or angles in triangles. And so I just wanted to review one thing, and that is that there are two specific instances where you should choose to use the cosine law versus the sine law. The sine law is always the easier of the two to use, and so I'd recommend you use it for non-right angled triangles first. Remember, I just want to emphasize that, I guess, to begin with, is that the cosine law and the sine law, I'm going to put a little star here, are for non-right angled triangles. Because if it's a right angled triangle, a non-right angled triangles, if it was a right angled triangle, you would use either Pythagorean theorem or SOHCAHTOA. They are much easier than either the sine law or the cos law. So there are two circumstances where you're going to have to use the cosine law. And so one of them is, I'll just draw two non-right angled triangles here. There's not that little square in the corner, so you can't assume anything here. And in this triangle, if I was given, let's say this side was 23 centimeters, and this side was 25 centimeters, and this angle right in here was 47 degrees. In order to get anything else in this triangle, you'd have to use cosine law because you are given two sides and a contained angle. So look at this. You're given this side, you're given this side, and you're given the angle between them. And so in that circumstance, there's no way that you can get an angle and its opposite side. Look at this. I don't have enough information to get this angle or this one because I only have the one. And I don't have the side that's opposite 47, so I cannot use sine law. In this situation, sine law does not work. I'm going to put sine law down and put an X through it. You can't use it. So unfortunately, you'd have to use cosine law. Okay, the other situation, I'll draw another triangle here. Maybe I'll try to draw it slightly differently. This one like this. And let's say in this case, you were given that this side was 4 feet, this side was 3.5 feet, and this side was, we'll say it's 8 feet. Okay, so in this case, you're given three sides of a non-right angled triangle. And again, we don't know any of the angles. And so because of that, we'd have to use cosine law. So again, sine law would not work. Sine law will not work in that scenario. So in these two types of triangles, where either you're given two sides and the angle between them, or three sides, you have to use cosine law. And I'll just remind you that cosine law can be written in two ways. If you were trying to solve for a side, you would write it like this. Little a squared is equal to little b plus little c. Those are all side lengths, minus 2bc cos of angle A. And remember, whatever side you're solving for has got to be the angle that you put at the end. So that's one way of writing it. The other way of writing it is if you were looking for an angle here, you could write cos of angle A is going to be equal to a squared minus b squared minus c squared all over negative 2 times b times c. So those are two ways of writing cosine law. They're identical, and we can use those. So let's give that a shot. We'll do a few different examples here. So here's one where it says solve for side DF. Okay, so notice that the first thing I'm going to see is that it's one of those scenarios where I have to use cosine law, because look at this. I'm given this angle, 67, and the two sides on either side. I'm not given enough to use sine law. So look at this. I'm going to go ahead and quickly label my triangle. So it's already labeled with a DEF, so I'll continue with that and call that side little d because it's opposite angle D. This side over here is little f. Remember, we always use little letters to define the sides. And that is there is capital E. That angle is capital E. So this side, DF, I'm actually going to label as little e. Okay, so it's asked me to solve for DF, which I know, according to my labeling, is little e. So watch this. I am going to write a version of the cosine law. So I'm going to go little e squared. Okay, here we go, is equal to the other two sides, so d squared plus f squared minus 2 times d times f, the same two sides we started with there, times cos of the angle E. So look at this, remember, it's whatever is there is also there. All right, so let's sub in here. So we're going to go 5.3 squared plus 3.7 squared minus 2 times 5.3 times 3.7 cos of 67 degrees equals. Okay, now I'm going to do this on my calculator. I want you guys to follow along with me because this is where students will often make mistakes. So here I go, 5.3 squared plus 3.7 squared, and I'm going to write it. Can you try it and make sure you get it? 41.78 minus, now here I go, I'm going to go 2 times 5.3 times 3.7 times, and make sure my calculator is in degrees, I'm going to go times cos of 67 equals, and I get there 15.324, etc. But I'm going to round it to 3, so there you go, I get those two. So please try those in your calculator, make sure you're getting the same as me. So 41.78 minus 15.324, and there I get 26.456. But remember, that's e squared, and the way you get rid of the squared is you square root, and that's going to give me e, but whatever you do to one side, you've got to do to the other. And so I'm going to go my square root, and I get 5.14. I'm going to go 5.1. I don't round it up because it was 5.14. I'll just put those other ones in there, 5.143 maybe. But because the other two sides are given to one decimal place, I'll just give it 5.1 centimeters. And I'm going to double check, and does that make sense? Yeah, it looks approximately right. Like if you had maybe forgotten to do that square root step and you'd tried to put the 26 in there, hopefully you'd look at it and go, well, that can't be right. That's definitely not 26. And so there it is, 5.1 centimeters. Okay, let's try another one. Here we go. It says determine angle A. So in this case, they want us to get that angle right there. And so again, I notice that I'm given all three sides. So if you're given three sides and no angles, you have to use the cosine law. So let's label these. Little c, this one is opposite angle A, so it's little a, and then this one's opposite angle B, so it's little b. Remember, you always label it based on the opposites. Okay, so we want the angle A. So the version of a cosine law that I'm going to use has to be A. Now I'm going to write it two ways for you, just so you can see this. So watch this. I'm going to write it like this. A squared is equal to B squared plus C squared minus 2BC cos of angle A. Look at that. It's got my unknown in it. Now, I'm going to rearrange this and write it the other way, is with this on its own. So cos of angle A is equal to A squared minus B squared minus C squared. Just if you're following along, you can see that I'm moving these two to the other side, divided by minus 2BC is going to give us the answer that we need. Okay? Just want to go back and look at something on the first page for a second. Perfect. Okay, so I just wanted to make sure that everything matched up. So here we go. So now let's substitute in. So I'm going to now work with this one. So cos of angle A is equal to, here we go, so 3.9 squared minus 5.2 squared minus 5.9 squared divided by negative 2 times 5.2 times 3.9. That's B, and oh, sorry, that was A. I've got to be careful here. It should be B, and C is 5.9. Let me fix that up. So here we go. So 5.2 was B, and C was 5.9. 5.9. Okay, so here we go. Let's do it in our calculator. So I'm just going to do it slowly. You can follow along with me. So 3.9 squared minus 5.2 squared minus 5.9 squared equals. So up top, we got a negative number, negative 46.64 divided by, and on the bottom, it's negative 2 times 5.2 times 5.9 equals negative 61.36. And so when I divide those, negative 46.64 divided by negative 61.36, I'm going to get a positive. A negative divided by a negative is definitely a positive. Okay, and so I get the answer of 0.760. But remember, that was cos of angle A. So to get angle A, we've got to do that little inverse cos function. So you go to your calculator and you do second function cos, and then answer, and I get roughly 40.5 degrees is my angle. Okay, we're going to try one more question here. We're going to try an application. Okay, I'm just going to finish off 2 application questions to help you with this. So here's one. An ice cream company is designing waffle cones to use for serving frozen yogurt. The cross section of the design has a bottom angle of 36. So there's the 36 degrees down there, and the sides of the cone are 17 centimeters long. Determine the diameter of the top of the cone. Okay, so you can see that in this case it's not a right angle triangle, and that we don't have any opposites, so we can't use sine law, so we'd have to use cosine law in this case. Okay, so here we go. I'm going to start by labeling my triangle. I'm going to call this one down here capital A, this one little a. I'll just call this one little b, this one little c. That would make this angle up here capital B, and this angle here capital C. Okay, so here we go. So we see that we need side A, and so I'm going to write my cosine law like this. A squared is equal to B squared plus C squared minus 2BC cos of angle A. Plug our numbers in. 17 squared plus 17 squared minus 2 times 17 times 17 cos of 36 degrees, not 63, cos of 36 degrees. Okay, we get our calculator out. You guys can try this along with me. Okay, so I get 578 when I add those two together, 17 squared plus 17 squared minus, and then I'm going to do that whole second part of it. So it's 2 times 17 times 17 times cos of 36, so minus 467.6. So now I do 578 minus 467.6. Make sure you're getting the same thing as me, 110.4. But remember, that was a squared, so we've got to take the square root of it. And so we get 10.5 centimeters. And does that look, yeah, it looks pretty good. It looks, you know, it looks reasonable. There we go. Okay. The last question I want to do with you here, this one they don't give you the triangle, so you've got to kind of, you've got to draw it yourself. And so it says, the posts of a hockey net are 1.8 meters apart. So look at this. I'm going to start drawing it here. So there are the posts of the hockey net, and I'll just join them, and they're 1.8 meters apart. A player tries to score a goal by shooting the puck along the ice from a point that is 4.3 meters from one goal post and 4 meters from the other goal post. Okay, so look at this. You can kind of imagine this, and the picture over at the side kind of gives you an idea, is that if the guy is shooting the puck, if the puck is, I'm going to just say it's right here, and that, and I know my triangle isn't to scale, but you can see that it's going to be, he could be 4 meters from this post. It's shorter, and 4.3 meters from this post. I know that that's not to scale. My 1.8 should probably be a little bit smaller than that, but essentially this is the distances given. So it says determine the angle that the puck makes with both. So really what they're looking for is that angle right in there. All right, so it's just you've got to be able to picture what's happening sometimes. So I'm going to call this capital A. That would make this little a. I'll call this little b, and I'll call this little c. That would make that capital C and that capital B. Okay, so we want angle A. So we know that cos of A, this is just one form of it, is going to be equal to A squared minus B squared minus C squared divided by negative 2BC. All right, well, let's plug our numbers in. 1.8 squared minus 4 squared minus 4.3 squared divided by, oops, I don't know what happened to my C, minus 2 times 4 times 4.3. Okay, so here we go. Let's see what we get here. So 1.8 squared minus 4 squared minus 4.3 squared equals, so I get a number of negative 31.25 on the top, and on the bottom it's negative 2 times 4 times 4.3, so it's negative 34.4. Make sure you're getting the same numbers, and then when I divide, two negatives will make a positive. So I get 0.908, but remember that was cos of angle A. So A is going to be the inverse cos of 0.908. And so I do the second function cos, and I get 24.7 degrees. So I would say, based on this, the angle between the posts is 24.7 degrees. Okay, I've put the homework questions on this file, so you can see them here, page 443 to 445, 3, 4, 9, and 11. And I've got the answers right here as well for you to check. So let me know if you have any problems. All right, everyone, take care and have a great day.